So in this video, I wanted to do a review of what are called functional groups. All right, and functional groups are just little parts in molecules. It refers to a specific combination of types of atoms and types of bonds. All right, and functional groups tend to be pretty important because functional groups, whenever you have certain atoms that are bonded together in a certain way, it tends to impart certain chemical or physical properties to those molecules. All right, so here are just a few examples of what I'm talking about. All right, anytime you have a hydroxyl group, all right, which we'll talk about in a little bit, which is just an OH, it will always increase the melting point or boiling point of that material. All right, so the reason for that is it increases the hydrogen bonding and it makes the molecules want to stick to each other a little bit more, and that's going to have. So just by looking at the structure, if you see a hydroxyl group is introduced, you'll generally automatically know that the new thing has a higher melting or boiling point. All right. Another thing, an amine. Right. If a molecule has an amine, which is a nitrogen with all single bonds coming from it, it's going to tend to be water soluble at low pHs, but it's going to be not water soluble at higher pHs. All right. Carboxylic acids are the opposite of that. All right. If something's got a carboxylic acid, it's going to tend to be water soluble at higher pHs, but not at lower pHs. All right. And one last one. This is actually an interesting one. You're not responsible for knowing what a thiol is, but I'll just show you here. This is a hydroxyl, all right, which is an OH. A thiol is just if the oxygen was a sulfur, so SH, all right, connected to it. This would be a carbon over here. All right. Anytime you have a thiol in a compound, it's going to smell like rotten eggs. All right. One type of molecule that has a thiol, actually it's what's called a thioether, is penicillin. All right. And if you have a bottle of penicillin or amoxicillin, if you smell that bottle, it's going to have kind of a bad odor to it. It's not anything like it's gone bad. It's just that the molecule itself that has a sulfur in it, that functional group, that just, whenever you have that functional group, it has that property. All right. So a little bit, I'm going to use a couple of abbreviations, and we're going to do this a lot in organic chemistry. A lot of times you talk about an R group. All right. Whenever you talk about an R group, it's going to be an alkyl group. All right. So an example of an alkyl group would be just some carbon chain. All right. It actually could be a single carbon. All right. The point is that carbon there is not going to be, it's only going to have, at least at the point of attachment, it's not going to have a double bond to an oxygen. All right. So if it was a methyl group, which is just a CH3, that would qualify as an R. All right. We'll see some examples of things that would not qualify as alkyl groups in a second. All right. Also, if you use an X, that's generic for any halogen. All right. So it could be fluorine, chlorine, bromine, or iodine. All right. So let's get into functional groups. All right. The first couple ones aren't actually what I would consider functional groups. They're just names for certain type of carbon compounds. All right. So when you say an alkane, all right, what it means to be an alkane is it's a carbon chain. All right. It could be branched. All right. You could have a carbon coming down here, but the important thing is that it only contains single bonds. All right. So this one right here, this is butane. That's what's in lighters. All right. This right here would be, so one thing I want to point out, as the noun, it's called an alkane, but if it's a substituent, if it's a group coming off of something else, it would be considered an alkyl group. All right. So hopefully you remember from naming, you want to find the longest chain that you have in the molecule. So there's actually two ways you could do this: 1, 2, 3, 4, 5, 6, 7. But you could also do 1, 2, 3, 4, 5, 6, 7. All right, and it's not a big deal which one you do, because either way, there's an ethyl group coming off. So here, this would be an ethyl group coming off of this, but this would be an ethyl group coming off of this. Either way, you'd name it the same way. So anyways, this right here, that's considered an alkyl group. All right, notice I don't say an alkane. So think of an alkyl as an adjective. It's an alkyl group. So when I name this, the name of that alkyl group is ethyl. All right, so ethyl is used as an adjective to describe something which is coming off of heptane. Heptane being that 7, 1, 2, 3, 4, 5, 6, 7. That's a heptane molecule right there that has an ethyl group coming off of it. All right. So that's one thing that you're going to notice is that YL tends to mean it's something that's used as an adjective. All right. So an alkene is an all-carbon molecule, and it's going to have a double bond in it. All right. So, for example, this molecule right here would be 1-butene. Okay, if you count the carbons, 1, 2, 3, 4. So it's butyl something or other, and we want to start from the side that gives it the lowest number. So we start from the side right here, and it's between the 1 and the 2 carbon. All right, so that makes it 1-butene. All right, so this right here would be, so if something's got a triple bond in it and it's all carbons, it's an alkyne. All right, so this right here, it's got 1, 2, 3, 4, 5 carbons. That gives it that pent prefix, and it's between the 1 and the 2 carbon. So we name it according to the first carbon that it comes from. So that would be 1-pentyne. All right. Okay. So even though the name of this right here is 1-pentyne, generically you could say that this thing is an alkyne. All right. So next one is a hydroxy or hydroxyl. All right. Sometimes those terms are used interchangeably. All right. So so a hydroxy is just an OH, but there's one condition on this. This has to be an R group. All right. And one thing about it being an R group is that one thing that it could not be is if this were a carbon with a double bond to an oxygen, or a double bond to something else. R generally means alkyl, all right? And the one thing is, you could have a bunch of single bonded carbons here and eventually have a double bond down the chain, but at the point of attachment, all right, this right here is going to be generally a CH or some sort of alkyl group. All right, there might be a couple of exceptions to that, but definitely not C double bond O. All right, we'll talk about why in a second. All right, so when a molecule contains a hydroxyl group, that makes that molecule an alcohol. All right, so for example, if this has got 2 carbons, all right, so if I just drew a line segment from, right off this right here, that would make it 2 carbons. That would be ethanol. All right, it's also called ethyl alcohol. And you would say that contains a hydroxyl group. All right. So just think of it. Alcohol is the name of the molecule, but hydroxy group is the name of the group that makes it an alcohol. All right. Next one is going to be an amine. All right. So if you say amine, you're talking about the name of the molecule. All right. But if you say amino, that's an adjective, you're talking about the name of the group that makes it the amine. All right. So an amine is going to be, and actually there's a little mistake on this. This is going to be an R group. All right. But I say NH2. This could actually be NHR or NR2. All right. So these could be either hydrogens or R groups here. All right. So an example of an amine is methylamine. All right. If any of you guys watched Breaking Bad, there's this side story of where they robbed the train to steal the chemical. That chemical was methylamine. All right. You would say methylamine. All right, here we're using amine as a noun. We're using methyl as an adjective to describe how it's the other part of the molecule. And you would say that it contains an amino group. All right, this is an amino group that's on that molecule, which you refer to as an amine. All right, so the next one is not necessarily a functional group all by itself, but it's a word that gets used in describing compounds. And that's anytime you've got a carbon double bonded to an oxygen. All right. And anytime you've got that, you refer to that right there as a carbonyl group. All right. And the thing about that is there's many different, I'm going to talk about a couple of different types of functional groups down here after this. And notice that all of these things have carbon double bond oxygens. All right. So what that means is that every single one of these other functional groups here has a carbonyl group. All right. So when they say carbonyl specifically, they're just talking about, like, for example, this part of this functional group. All right. So, for example, you would say that this is the carbonyl carbon of this aldehyde. All right. Or this is the carbonyl oxygen because it's part of that C double bond O. All right. So that leads into these types of functional groups that have carbonyl carbons. All right. The first one's going to be an aldehyde. All right. That's going to be this one right here. We've got what makes it an aldehyde is it's a hydrogen coming off of that carbonyl carbon. All right. And this over here has got to be a carbon. All right. So this R group, it's got to be a carbon. All right. So for an example is this would be propanal. All right. And when things end in al, that means that it is an aldehyde. All right. Oops. Move these guys. All right. So next one is going to be a ketone. All right. I actually made a mistake. There should be an R group right here. All right. So put an R group right there. So what makes it a ketone is that on both sides of the carbonyl group, you have R's. All right. So this has got to be a carbon. This has also got to be a carbon, and it can't be a carbon that's double bonded to an oxygen. All right. So best example of this is this one right here. This is acetone. It's the classic compound that's in nail polish remover. All right. That's a methyl group. That's a methyl group. So it fits that generic formula of being a ketone. All right. So this right here, the next one is a carboxylic acid. All right. And so again, you have a carbonyl carbon. You've got your R group, which means this has got to be carbon over here. And instead of a hydrogen like you have in the aldehyde, you have this OH right here. All right. So this entire part right here, all of those parts are necessary for it to be a carboxylic acid. All right. So classic example of this is what's in vinegar. All right. This is, if we named it through IUPAC, this would be ethanoic acid because there's 2 carbons in it. That's an ethyl base word. That's where the F comes from. However, the more common word for this is acetic acid. All right. You know, I don't know of anybody that would ever no one would seriously refer to this as ethanoic acid in a laboratory. All right. This is acetic acid. And hopefully you recognize that if this is if you take that hydrogen away and just represent the A- of that acid, that would be acetate, which is one of the polyatomic ions on the board. So one thing I want to say about this, if you just looked at this part right here, that's an OH, all right? And you might say, well, isn't that a hydroxyl group, all right? Because that's what we defined up here. And I want to point out that this right here is not a hydroxyl group. In order for this to be a hydroxyl group, it's got to be an R, all right, which means it cannot have a carbon double bonded to an oxygen right here. All right, so since this right here, that would be a carbon double bonded to an oxygen, that this is not considered a hydroxyl. All right, and it might seem like a trivial difference. Why not call it a hydroxyl? It looks like a hydroxyl, and it has to do with the concept that functional groups generally have the same type of chemical and physical behaviors. All right, so one important thing is, you know, you might say, well, how hard is it to pull this hydrogen off? How acidic is that hydrogen? All right, well, as a hydroxyl group, this is not very acidic at all. You'd actually have to use a fairly strong base to pull that hydrogen away, that H plus away from a hydroxyl. All right. However, as a carboxylic acid, it's really easy. All right. That's why it's a carboxylic acid. All right. That's where the acid term comes from. This hydrogen right here, you know, it's a weak acid, so it's not going to totally dissociate. But if you put this into water, substantial amounts of this, water is a strong enough base to pull off a substantial amount of this, so that makes it an acid. All right, we'll continue with this in the next video.